Today, we'll be talking about uncompromising Web3 communication at scale with Waku. So, introducing Waku, it's a family of robust censorship-resistant communication protocols designed to enable privacy-focused messaging. The 6 values of Waku are listed over here. It's private, it's censorship-resistant, completely modular, adaptive, securely scalable, and rate-limited. So talking about the history, it all started with the Ethereum white paper in 2013 when the Ethereum trilogy was introduced, where Ethereum was said to be the consensus layer, Swarm for the storage layer, and Whisper for the generalized messaging. But over the years, there was not much of dedicated teams building on top of Whisper. And then in 2020, Whisper was replaced by Waku V1 in the status app. So this was a benchmark year, and today, Waku has evolved into a standard of Web3 communication. When I say standard of Web3 communication, it's because of the ecosystem that we've built around. We have status app using Waku, Railgun, which is a privacy layer built on top of Ethereum using Waku. The graph is using Waku for decentralizing their indexes, and also XMTP is using Waku to build a specific use case, which is chat. So the key features of Waku are it's adaptive. It can cater resource-restricted environments like browsers, mobile phones, to resource-intensive environments like clusters, VPS, home servers and stuff. So it's highly adaptive. And it's rate limited by nature. We have rate limiting nullifier, which is a truly decentralized and anonymous rate limiting technology using ZK proofs. It's also open and permissionless. So Waku works on a content topic-based architecture, and anyone can pretty much push messages into a content topic and subscribe to a content topic to retrieve the messages. To get started with Waku, you have 2 ways of doing it. The first one is to operate a Waku node or to build on top of Waku. For operating a Waku node, you can do it with nwaku or Docker or Docker Compose command or even dap node, which is just a few clicks for initializing your own Waku node. If you are looking to build on top of Waku, we have the following implementations, which is JS Waku, nwaku, Golang, Rust bindings, and C bindings. You can find all of these codes and SDKs open sourced on our GitHub. So the 4 main resources that I want to share here are the developer documentation, which is available at docs.waku.org, and we also have a list of example apps that use Waku. You can check it out at examples.waku.org, and you can also find the GitHub repository in the organization. And yeah, the GitHub has all the open source code, and we also have an RFC list, which pretty much has the specifications for each and every protocol in the Waku ecosystem. So I would definitely encourage you to check it out if you are digging deep into Waku. So for ETHGlobal Istanbul, we have bounties worth $10,000 up for grabs. So the first prize or the grand prize winner will be getting a $4,000 bounty for the best implementation of Waku. And we also have 4 different track prizes with $1,500 each. The first track will be Best Network State Goods with Waku. The second being Most Creative Use of Waku. Third being Privacy-Focused Projects built on top of Waku. And the fourth one will be Best Game or Marketplace built on top of Waku. One thing that I wanted to highlight is that we don't really encourage general chatting apps or traditional chatting apps. We are looking for more novel use cases through these hackathons. So try to be as innovative as you can. And yeah, we're expecting the projects to be in those levels. So finally, some use cases with Waku. You can build gaming apps, marketplaces, decentralized state channels, or anything that can be done with human-to-human or human-to-machine communication. You can also check out our curated list of ideas by the community at ideas.waku.org, which has around 50 ideas. You can also feel free to contribute to new ideas in the community. So we also have a Discord server for us. Feel free to drop in and ask your questions, and our developers are ready to help you out for the hackathon. So I'll have my friend Danish to do a quick demonstration of the JS Waku SDK. So we'll be building an app in the next 10 minutes.
Awesome. Hello. I'm Danish. I'm a JS Waku maintainer. So for this quick workshop, we'll build, and Guru mentioned we're not looking for a chat-based example. So we're going to build a super simple app that gets you to vote on a specific question. So you'll have four options, and there's going to be a question. And generally, You'd go around doing that by using some sort of a backend, right? But for this case, we're going to use Waku as the networking layer for it, and we're going to propagate the answers of the users through Waku, and everybody's going to be able to see that. So I'm going to assume, does everybody here know about Next.js, like starting a Next.js project, right? Okay, so we'll skip that part. We'll go into a project that has Next.js set up, and you can use whatever front end you want, right? The second thing what we're going to do is we're going to have the basic front end laid out. That is not as important for the workshop, right? Front end can be whatever. We're going to focus on providing or integrating Waku as a networking layer to communicate the votes. So I have the project called Waquiz, right? And it's in Next.js. So opening this and zooming in, this is the basic Next.js structure, right? We have these config files, post.css for some styling stuff, and what we want to look at is the app, right? Here we have the layout.tsx, which is by default comes with Next.js, so we're not much concerned about this. What we're going to look at is page.tsx, right? And here, this is the logo. We're not going to care much about the front end stuff. What is going to be interesting here is 4 things. We're going to keep it very simple. What do we want? We want to have a node. We want to be able to connect to the network. We want to send messages into the network and receive messages into the network. Now, what is this message, right? Let's start with defining the structure of the message. We say we have a question with 4 options as its answers. So we want to send or propagate knowledge about the question. The question is of, let's say, structure. It has an ID, which can be unique. The question itself, which is of string. The answers, the possible answers, and the correct answer. So defining the type, we're going to define a very simple interface. It's going to have ID, a question, and an answer, which is the array of strings. Let's skip the protobuf definition for now. This is useful when we're sending the message into the network. Going back to what we decided, we need primarily 4 things. We want to start a node. We want to connect into the network. We want to get messages from the network, right? And we know what a message is at this point. A message is simply an object which has an ID, a question, and an answers key. So creating a node, right? Let's use this for reference. Let's comment this for now, and let's start from scratch. And let's also open the docs on the side, because that's how I wrote the code and how we should expect to write or get started with Waku. So going to docs, nodes and SDKs. Here you'll see all the implementation docs. Going to Waku SDK, let's go to sending and receiving messages using light push and filter. Light push is a light protocol that is used to push messages into the network, and filter is used to subscribe messages from the network. So that's all that we care about right now. Now, creating a light node. Creating a light node is literally just 2 lines of code. So we'll go here, go back to waku.ts, which is a file for us to keep all our utility functions. And let's call this create node. And it does not take any arguments. And that's what it does, right? Missing up. Yeah, perfect. It create light node, and we're passing it a parameter called default bootstrap. And what that does is it uses a predefined set of nodes that we're going to use to connect to. Otherwise, if you do not want to connect to pre-existing set of nodes that Waku has, Waku being a permissionless network, you do get to run your own node and participate in the network, and you'll get a multi-address that you can use to dial. So you do not have to use a pre-existing node. For simplicity, we're going to use the default network, and we're going to start the node. One key point here is going to be we are attempting connections to the network now. We have to wait to ensure that we can use the protocol now. So one simple helper function here is what we call as wait for remote peer, and we're going to pass it the node. This function is pretty much all it takes to create a node. And at this point, if this function just returns cleanly, this means you are connected to the network, right? And now what we want to do, we want to be able to subscribe to the messages from the network. To do that, let's see how we do that. We've waited for remote peer, and everything happens. It's a pub-sub architecture, so everything needs to be over a content topic. For this, we've set this content topic, and it can literally be anything. It can be ETHGlobal Istanbul, and it doesn't matter, right? Or we just need to ensure that the content topic we choose is unique to our own application. The next thing we want to do is, of course, we're going to be sending messages into the network and receiving messages from the network. And we used protobuf, right, to keep it. Yeah, we're going to, OK.
Do you accept questions?
Sure, yes.
Why we have to use protobuf?
Because we are interacting with multiple implementations. So we need a way to serialize the message.
Can arbitrary byte for my own protocol?
Yes, you can. Yes, you can. So you can encode it. All it needs to be, So it needs to be serialized and deserialized in a particular standard, which is why we stick to protobuf, but you can send it however you would want. So to send and receive messages into the network and from the network, we, of course, have to set up encoders and decoders to know how we want to serialize and deserialize the messages. And it's as simple as creating encoder and creating decoder and passing it the content topic. And all of these helper functions come from one package, which is at waku/SDK. Everything you need comes from this. Now, to subscribe to incoming messages, now that we've set up our encoders and decoders, and we already defined the message structure, actually. Going back to the interface, this is exactly the structure that we also want to use for protobuf, in case we use protobuf, right? And it's as simple as just creating a new type and adding all the fields to it. Now, assuming we also have the message structure sorted, we're going to come to sending messages in a second and focus on receiving messages from the network first, right? The function or the protocol we are interested in is the filter protocol. And let's just create a subscription object using this. Let's call this subscribe to incoming votes, as we did. And this takes in a few things, but we'll focus on writing the code to see what we want. OK, so we'll need a node for sure, right? And the node is of type a light node, and the types as well come from the same package. The next thing we want to do is, well, we have the subscription object, but when the messages come to us, we want a way to decode the messages correctly, right? So we pass it the decoder, and it's going to help us process the messages. So we pass it this, and the callback here is what you want to do with the message, right? So we're going to define a little callback here. Let's call it callback equals to, and this is going to have the decoded message. So let's call this the poll message, and it's of the type decoded message. And let's just do, well, found decoded the message, right? Cool. And the next thing we're going to do is, like, of course, pass it the callback, and that is it. That is it, right? This other thing we can do here is to get a callback from the user, right? Because the callback we've defined inside is just to decode the message. So yeah, to decode this, we're going to have to use the protobuf definition and decode using that. So the decoded message, this will be not the format we expect to get. So for that, let's see what we want. We'll want to see the poll message.payload if it exists, right? If it does not exist, well, we don't want to deal with it. If it does exist, we'll create the poll message object, which is going to be, well, p-poll message, which is our protobuf definition, and then decode using that. And yeah, so now this is going to be our deserialized message. The serialization, deserialization can seem a little bit more, adding more friction, but in reality, once you set it up for the first time, it's pretty seamless. Once we have this, then we're gonna go to sending the vote, right? We've set up how we can retrieve votes that are coming in live. Now we want to send messages into the network or send our option into the network. So let's set that up. And this takes in what? Let's see, we're gonna use light push. So we gotta create a proto message. And in this case, the chat message is not right. It's called p-poll message. And the things that it wants is an ID, a question, and the answers, right? So we got to pass it in arguments, because we're going to use some front-end magic to basically just automatically send it to this function. So let's pass it a variable, which is, well, our vote. And this is of the type iPoll message. And we're going to create this, our vote. And now next thing we want to do is we want to serialize this. That is done. And, well, we just send it. And we want the node that we send it with. And we're going to use light push this time. So light push is to push the messages into the network, and filter is to retrieve the message from the network. The node here is going to be of the type light node. And, well, that is it. The next thing is, now that we have our utility functions, right, let's not focus on retrieving existing votes for now. But this is another protocol, which is the store protocol, right? And this comes in handy when, let's say, you're offline, but you still want to know, without being online, what are the messages that were sent while you were away. So the store protocol stores your messages for an arbitrary number of days. I think it's 30 days for now. And after 30 days, it just wipes the data away. Okay, now that we have a way to send a vote, subscribe to incoming votes, and creating a node, that is literally all we need. Going into our root of the app, right, which is page. This is our logo and some loader stuff. Now within use effect, well, we can just remove this. We're gonna create a state, right, which is gonna hold our node, because we wanna pass this node around throughout the application, and you can use some more central state management things. But for this use case, we're just gonna stick with use state. The next thing we're going to do is we want to call this asynchronous function. So we're going to do some janky stuff. And within use effect, we're going to create the node and set the node and then call this function. Void is not assignable. OK, so we actually had to return the node. We did not return the node here, right? So we returned a node here, and this error goes away. OK, now we expect to have a Waku node initialized as soon as the app mounts. The next thing is the poll itself, right? And to simplify all of this HTML, we have a question. We have 4 options, right? The questions are being mapped on. The answers are being mapped on to render, and that is all we care about. And then there's an on click that handles the vote being sent. So what is happening, except sending the vote, is you're listening to the messages. You want to listen to the messages that are incoming, and you want to, let's say, increase a counter on your options. Now, for that, we need to subscribe to our events, for which we already have a utility function. And the second thing we need is a way to send the message into the network. So for that, let's write our handle vote send. And we have this function called send vote, right? it takes in the node itself and the vote message. There are multiple ways you can architect this. You could create a class, and then you would not have to pass the node every time. There are multiple ways you can go about this, but for simplicity, we're going to stick with this. So what you do is you get the index, you find the vote object, and all you do is you just send it, you just call this function. Now what it does in the background is it creates the proto message for this, it serializes it, and then it passes it as the payload. Now one little nuance here is that over light push, the maximum payload size is 1 MB, and not the payload size. It's actually the entire encoded, entire serialized message cannot be over an MB. But most things should not cross an MB. It's a very generous limit in my personal opinion. Cool. Now that we know how we handle sending votes, the next thing is we're also listening to how you receive votes. And we want a counter to increase. So we have this little function that takes in the poll message that is received and finds the index for that option that is received and just increments the counter, right? Not as readable, but it is pretty straightforward. All it does is parses through the, loops through the object and finds the option and increases the counter. Now on use effect, well, we handled sending votes. The next thing we want to do is subscribing to events, right? And we have a function for that as well. Subscribe to incoming votes. That uses filter, and it takes in a callback, right? Now that callback is actually our process received votes that increases the counter. So what that, here we're gonna call our subscription function, and that is pretty much it. So just to recap, and we're gonna do a little small demo of what we've built here. I know we have not focused on front end because that was not as important, and I think everybody here who's trying to play around with stuff would be able to figure that out. But what we care about here as well, we were successfully able to interact with the network, use it for a use case to propagate messages between peers, and in a decentralized manner. So the Waku network is permissionless. As Guru mentioned in the talk previously, you can operate a node right now. You can participate in the network yourself. There is no incentivization, but it is still permissionless and censorship resistant. So without using any centralized service, we were able to make a peer-to-peer application that scales. And to see how it looks like, if anybody of you have wanna interact, open your phones or your laptops or any machines, and the URL is wa-poll.vercel.app. And what we've made on this application is deployed here, and the code is on the GitHub as well that we can link. And what you're going to see as you open your on your website is going to be a loader that says connecting to the network. The URL, of course, sorry. Is that visible? wa-poll.vercel.app. And as you vote, somebody voted, and we're going to see the voting counter increase. And one thing to note here is, okay, so somebody thinks the taxis are the favorite part. Well, Guru would disagree. Guru got scammed yesterday. You're the one who voted it. Well, so the interesting part here is that, well, there is no centralized server involved. We're connected to a decentralized network, which is peer-to-peer in nature. And, well, that concludes our presentation. The use cases are endless in terms of Waku being a networking layer. It is very modular. Chat applications are the most direct and the naive use case. And we have seen some of the community projects and partners do that. We also have, as Guru mentioned, projects like Railgun that use it for their private blockchain. Then we have Silence Labs that use it for multi-party computation. Silence Labs, yes. Not Silent Protocol, Silence Laboratories. They do multi-party computation. So we're looking for these novel use cases, and as Guru already expanded, two people seem to think taxis are the favorite part about Istanbul. Well, that is all from my side, and yeah, okay, questions, please, yes. Yes, so that is a very important point. Waku does not link any identity to your session, to your message, right? So every time you refresh, well, let's say I vote here, right? And now the input boxes are disabled. Well, that's a front-end thing, right? You can just inspect the element and you can play around with that. So to sort of enforce some sort of identity, we expect the application layer to integrate their own solutions, and that is how the sort of modularity into the protocol comes in. Waku is strictly used for the communications bit, the message propagation bit. Everything else is can be integrated with it. So you can attach a wallet here, and we have some examples on our GitHub, examples.waku.org, and some of them use wallet connection as an identity. So yeah, you can be creative, you can be novel about it, and sort of play around with it. Yes?
Yeah, how do you prevent spam?
Amazing question. So spam and DDoS protection is something Waku and its research entity WAC has been thinking about and solving for a very long time. In tandem with PSE, and Alvaro here is here, who actually implemented it for Waku. Thanks to him. So there is an algorithm called RLN, which stands for rate limiting nullifiers, which uses ZK, and he's probably the best person to answer this. So there's a membership set, and it's deployed on some chain. It's Sepolia for now. We're testing it out on a test net.
Membership, you mean using something like semaphore or something like that?
Yeah. And you register into the membership set, then every time you send a message, you have your proof attached to your message, right? And it is capped. There's a cap on the number of messages you can send into the network. And anything that does not have a proof attached will still be able to send, but it'll not be prioritized. Is that correct, Alvaro?
Yeah, we are still thinking about that feature.
Yeah.
What we have right now is that if you exceed the limit that RLN imposed to you, then your message is going to be discarded. And any peer that sends invalid messages or spam messages, we have a scoring system, and we will de-score your peer, and the rest of the peers will end up kicking out you of the network. So at this point, we don't have any like free bandwidth that you can use without this RLN proof. But this is not imminent yet. We are releasing this next week.
So there is a type of identity anyway.
It's a pseudo identity because it's not connected to any on-chain identity. Because if the synchronous proof that you attach into the message, you prove that you belong to a given tree of whitelisted entities, but you don't reveal your identity. And assuming that you broadcast, I mean, you have to register your membership on-chain, right? Assuming that you broadcast this message that inserts your membership into this tree with a gas station, if you're aware of this, no one will be able to map the message with any on-chain identity. So it's very, very relevant.
And anybody can create these groups?
Yes, we have a contract. You have to pay some fees, and then you can join. But it's permissionless. And we will be releasing a testnet. I mean, we have the testnet, but we haven't announced it yet. So if you're interested in that, next week, stay tuned to our Discord. We will announce it.
Do you want to open the QI for the Discord? Any other questions? All right, thank you so much. We'll be around we have a booth on the left. We'll be around to entertain any questions, any sort of help you might want. And of course, Discord is also a great place to get very prompt assistance. All right, thank you so much.